Hi, Namaskar. Today we are going to discuss about the isomerism. Generally, isomerism it look very simple and very easy, but the thing is that what I observed in my 18 years of experience, the student making mess of it when they are writing in the exam, because while they will be listening, it look very simple. They will be think like that. Okay, isomerism this much simple, but while they are writing in the exam they are writing in the different way only. That's why just will be go through this one. Hardly I will take 10 to 15 minutes. Please go through it. This is called the isomerism. Means they are having the same chemical formula. Chemical formula is same for both the structures. Generally here listen carefully, we are not taking one structure. In this case we are taking the two structures, two components in sense. Means we are comparing with each other, but what generally they are doing, students, means they are presenting only one example. That is the big mistake they are doing. It means what? Same chemical formula, but they are different in the structure. How it will be? I will give the example for this. This is called as the N-butane. See, we will be take another structure. See here, this is called as the 2-methyl propane, or we can be represented as the isobutane. We can call as the isobutane also. Here one is the N-butane, this is the normal chain butane, another one is the 2-methyl propane. Just see what the difference in this case you are observing. Both they are having the same chemical formula. How it will be generally when you will be see, both they will be having the same chemical formula. How many carbons this one have? 1, 2, 3, 4. Total how many carbons? 4. This side you see 1, 2, 3, 4. Total carbons are the 4. See the hydrogen 3, 4, 5, 6, 7, 8, 9, 10. H10. This side also see 3, 3, 3, 9, 9 plus 1, 10. It means what? Here both they are having the same chemical formula, but the structure is different. This is called as the N-butane. This is called as the 2-methyl propane or isobutane. Structure only different. This is the normal chain. Okay, this is the branched chain. Here this is the difference we are observing. This is normal, this is branch. This is exactly called as the isomerism. But here generally we are having the two types of isomerism. How many types of isomerism? Two types of isomerism. What I told, isomerism is two types. One is called as the structural isomerism. Then another one is the stereoisomerism. One is structural isomerism, stereoisomerism. Both the mean same here. It means having the same formula, but the different in the structure. In case of stereoisomerism, there is a stereochemistry will be different, but the formula will be remain same. But the arrangement of the group around the space of the molecule, it is different. That is called as the stereoisomerism. That I will explain you with example, then you will be better understand. Now we will go for the first one, structural isomerism. Here structural isomerism, it is classified into 6 types. Chain isomerism. Second one is the positional isomerism. Positional isomerism. Then third one is the functional isomerism. This is the third one. Fourth one is the ring chain isomerism. Fifth one is the metamerism, and the last one, sixth one is the tautomerism. See, structural isomerism classified into 6 types. First one is the chain isomerism, positional isomerism, functional isomerism, ring chain isomerism, metamerism, tautomerism. Okay, when comes to the stereoisomerism, it is 2 types. First one is called as the geometrical isomerism. Second one is the optical isomerism. Okay, we'll be discuss one by one here. Okay, how many types I told? Structural isomerism, 6 types. One is chain, positional, functional, ring, and metamerism, and tautomerism. Then we'll go one by one. First we'll go for the chain isomerism. Example already I given while explaining the definition. This chain isomerism, best example is the N-butane to methyl propane. In this case, what I told, both they will be both they are having the same chemical formula. How it will be? 4 carbons, 1, 2, 3, 4. Then hydrogens how many? 3, 4, 5, 6, 7, 3, 10. H10. In this case also you can see 1, 2, 3, 4. 4 carbons, hydrogens how many? 3, 3, 3, 9 plus 1, 10. It means both they are having the same chemical formula, but they are different in the structure. That's nothing but the different in the chain. One is the normal chain, another one is the branched chain. One is the normal chain and another one is the branched chain. This type of isomerism we are calling as the chain isomerism, but they are different only in the chain. Okay, but having both, they are having the same formula. In the exam you have to be represent like this, but generally students what they will do, they will write only one. For example, like this, CH3, CH2, CH2, CH3, and they will be write C for H10. This is called as the chain isomerism. How we are going to justify for this one? No justification. When you are going to be justify? When you comparing both. That's why in the definition I told 2 or more compounds. 2 or more organic compounds. They are having the same chemical formula, but they are different in the structure. Same molecular formula, but the different in the structure. That's why this is the justification for this one. This is completely wrong. We should not explain with only one structure. In case of positional isomerism, here also again same molecular formula they will be have, but the position of that functional group which is present in the structure or any double bonds which are present in the structure, that will be different, or any substituent present in the structure, that will be different, means attached at the different position. If I will say with the mouth means you may not understand, but if I will give the example, now you can understand. In the case of positional isomerism, example you can see, the name for this one is the propane to all, because here alcoholic group. Here also it will be having the same functional group, that is the hydroxy group. Here also same functional group, that is the hydroxy group, that is the alcoholic group. This one is known as the propane 1-all. Okay, or you can call as the 2-propanol or 1-propanol. Okay, 1-propanol, 2-propanol. See the difference is what? What is the formula it will be have? How many carbons? 1, 2, 3. C3. How many hydrogens? 3, 4, then 3, 7, then 1, 8. Total 8 hydrogens, H8. Then oxygens, how many? 1 oxygen. In this case also it should be same. See, 3, 4, 5, 6, 7, 8. 8 hydrogens. Carbons, how many? 1, 2, 3. 3 carbons, 1 oxygen. Means what here? Formula will be same. Molecular formula will be same for the two compounds, but they are different in the position of the what? OH group, position of the alcoholic group. Okay, one is present at the first position, this one. Another one is present at the second position on the second carbon. Okay, that's why the position only it will be different. That's why it is called as the positional isomerism. But here many of them they will be confused with this functional isomerism. What I told in case of positional isomerism, whether it may be functional group, either it may be double bond, the double bond position, functional group position, it will be vary, but both are the same. Double bond position means, I will give another example, you will be understand by this. For example, you can see another example I will give. Just see this one, what it is called? 1, 2, 3, 4. Second position double bond is there, and it is 4 carbons. It is called as the 2-butene. This one is called as 1, 2, 3, 4. First position double bond is there. That's why it is called as the 1-butene. 2-butene as well as the 1-butene, both they will be having the same formula. Molecular formula. How many carbons? 4 carbons, C4. How many hydrogens? 3 plus 1, 4 plus 1, 5, 5 plus 3, 8. H8. But the difference is what in this case? Difference is the position of the double bond. In one compound, it is present double bond at the second position. Another compound, it is present at the first position. That's why they are called as the positional isomers. Either it may be what it is called functional group position, either it may be double bond position, if it will be only the different in the structure. Okay, molecular formula remain same. That's why they will be called as a positional isomerism. Generally what happens means, the positional isomerism, functional isomerism, the student they will be get more confusion, because functional isomerism means functional group. Here also functional group, but what is the difference between the positional and functional? That I will tell you. I will write the example, you will come to know. I am not erasing this one because you have to see the difference. Example you can see. This is called as the propane 2-one. This is called as the propanol. See the difference here. One is on, another one is all. But in this case you can see both are all the OL. But here one is on, another one is the all, is nothing but this is the ketone. This all is nothing but this is the aldehyde. See the formula. What formula it will be have? Carbons how many? 3 carbons, C3. Hydrogens how many? 3 plus 3, 6 hydrogens. Oxygens how many? 1 oxygen. In this case also see 6 hydrogens, 3 carbons, 1 oxygen. Both they are having the same molecular formula, but what is the difference we will be observing? It is different in the functional group, because this is the ketone and this is the aldehyde. This is ketone, this is aldehyde. But in this case you can see this is also alcohol, this is also alcohol. It means functional group is same but the position is varying. That's why it is called as the positional isomer. But in this case functional group is different. We are not thinking about the position in this case. Functional group only different. Functional group different means no need to see the position. No need to see the position because they are having the different functional group. That's why it is called as the functional isomerism. This is called as the positional isomerism. Functional isomerism, see here, this is ketone, this is aldehyde, but in this case you can see this is alcohol, this is also alcohol, both alcohol, but the position only different. That's why they will be called as the positional. In this case functional group is different, molecular formula is same. This is the ketone, this is the aldehyde. Now fourth one is the ring chain isomerism. I hope you might be understood these three: chain, positional and functional. Don't be get confused. Okay. Now in case of ring chain isomerism, this is called as the cyclopropane. This is called as the propene. See the formula for this one. Molecular formula 3 plus 1 4, 4 plus 2 6, H6. See in this case also 3 carbons. How many hydrogens? 6 hydrogens. Means what? Molecular formula is same here also, but they are different. One is in the form of open chain, another one it is in the form of ring. That's why this type of isomerism what we are calling ring chain isomerism. Ring chain isomerism. The connecting only different. The connection around the carbon it is different. Here all the carbons they are connecting together, but in this case no. These 2 carbons are free. That's why one is in the chain form, another one is in the ring form. That's why this type of isomerism we are calling as the ring chain isomerism. I hope you might be understood this one. It won't confuse. See, this is also ether. This compound also ether. But what type of ether this one? This is called as the methoxypropane. This is called as the ethoxyethane. Ethoxyethane. Okay, because here we are calling as the ethoxy, that is the alkoxy alkane. This is the IUPAC name what we studied in case of especially ethers, how we are going to give the IUPAC name, which will be the smaller carbon attached to oxygen, that we are calling as the alkoxy. In this case both the side all the ethyl group only. That's why you can take this ethoxy, this side also ethoxy. That's why I wrote ethoxyethane. But here methoxypropane. But you cannot call as the propaxymethane because it is against the nomenclature. Okay, which is the smaller one we are choosing. That's why we are calling as the methoxypropane. This is also ether. This is also ether. But what is the difference here in this case? The functional groups are the same, means both are the ethers only, but the see in this case molecular formula what it will be having 1 2 3 4 carbons. How many? 4 carbons. In this also 4 carbons, hydrogens 3 4 5 6 7 8 9 10, hydrogens 10. Okay, 5 plus 5 10, and oxygen is 1. In case of metamerism is nothing but, listen carefully, around the functional group there is the difference in the number of carbons. means difference in the number of carbons around the functional group. That type of isomerism is called as the metamerism. They are having the same molecular formula, but around the functional group there is the unequal, remember this word, unequal number of the carbons. See here, this side 1 carbon, this side 3 carbons. This side is 1 carbon, but this side is the 3 carbons. See, there is the equal distribution? No. 1 carbon, 3 carbon. In this structure you can see 2 carbons around the functional group. Here 2 carbons. What is the difference between these two structures? Molecular formula is same, but around the functional group the number of carbons, they are unequal. In this case 1 and 3, in this case 2 and 2. 1 and 3, 1 and 3, 2 and 2. Different or not? Around in this functional group there are the 2 carbons, but in this case 1 carbon and 3 carbon. That only the difference, okay, around the functional group. Molecular formula is same. That's why it is called as the isomers. But the different around the functional group, unequal amount of the carbon in these 2 compounds. Don't compare here. You might be say, sir, 2 equal amount of carbons are there. Here also 2, here also 2. No. Compare with this structure. In this case 2 carbons. In this case 1 and 3. Unequal distribution is there or not? It is there. 1, 3, 2, 2. Unequal distribution. If this side also, for example, you might be see 2, 2 and this side also 2, 2. Means at that time it is difficult. We cannot call as the metamers. When we will call the metamers, number of carbons will be vary when compare one structure with the another structure around the functional group, but the molecular formula it is same. That is called as the metamerism. I hope you might be understand. Next one is the tautomerism. Tautomerism also called as the keto-enol tautomerism. Remember this. Then we can see here 6th one, tautomerism, that is keto-enol tautomerism or tautomerism. These are the special type of isomers. Both the isomers, they are dynamic equilibrium with each other. How it will be means, I will write one example, then easily you will come to know. See, in this case, this is in the form of keto. This is in the form of enol. That is the alkenol, means alkene having the alcohol. That's why it is called as the enol. That's why it is called as the keto-enol tautomerism. They are dynamic equilibrium with each other. Means this one will be converted to alcoholic form, means ketone will be converted to the alcoholic form, or alcoholic form also converted to the keto form, but the molecular formula will be the same for both, not the different. How it will be? See, how many carbons? 3 carbons, C3. How many hydrogens? 3 plus 2, 5 hydrogens, 1 oxygen. See here, 2, 4, 5 hydrogens, 3 carbons, 1 oxygen. Molecular formula is same, but one is in the form of keto, another one is in the form of enol, and both they are dynamic equilibrium with each other. Means this will be converted to keto form, converted to the enol form will be converted to the keto form, but the keto form is 93% it is stable due to this ketonic group. Remember this. Due to this hydroxy group, it is stable only 7%. But see how it will be converted to the keto form into the enol form. Just see what happens here. This will becomes here. It forms the double bond. These electrons will be go here. When it will be go here, these electrons, it will be take up the hydrogens. That's why it becomes OH. And it will becomes double bond. due to here transfer of the electrons, it converted to double bond. Again you can see what happened. This electrons will be come here, it forms the double bond, and this electron have to be go, one is coming means another one it have to be go here, that's why it will be move here, then it will be converted to, and this hydrogen will be come here, that's why it will be converted to the keto form, because here electrons will be move, no, two electrons, that's why this hydrogen will be come here, because this electron it gives to this hydrogen, these electrons will be move here to form the ketone. It means what here? Keto form converted to the alcoholic form, then alcoholic form also converted to the keto form. But in this case, in the competitive exams, they will be asked which form is more stable in the keto-enol tautomerism. Means you have to write keto form is more stable. Why it is more stable means due to this ketone, double bond O group, ketonic group. That's why it is called as the keto-enol tautomerism. This is the structural isomerism. I hope you might be understood this. Next we will be go for the stereoisomerism.